Hello, the title of this section is Multiplexing and Switching. Therefore, two concepts will be explained here. We will start with multiplexing in trunks, and then we will explain three different switching approaches. Multiplexing is about how multiple users' conversations can share a single channel, which is called as trunks here. Two categories of multiplexing schemes are used to multiplex many conversations over a single physical trunk. The first scheme is called FDM, Frequency Division Multiplexing. In FDM, the frequency spectrum is divided into frequency bands. For fiber optic channels, WDM, wavelength division multiplexing, is used. It works in a similar way with FDM. Now, wavelength range is divided for different conversations to use. The second scheme is called as TDM, time division multiplexing. In TDM, the entire bandwidth is used for a chunk of time period. Each conversation takes a turn to use corresponding time trunk. The frequency division multiplexing can be demonstrated as the following example. For three conversations, their original frequency range are the same. In order to multiplex them on the same trunk without interfering each other, we need to raise their bandwidth to different frequency range. Therefore, when they are all transferred on the same trunk, their frequency range can separate it from each other. For time division multiplexing, time is divided into chunks, which are allocated for different conversations. Here, we can use T1 and the T2 network as an example. T1 network uses TDM. It allows different users to use entire bandwidth within its own time chunk. T1 network can even be multiplexed into higher carrier, such as T2 network. And this hierarchical multiplexing can continue into even higher carriers, such as T3 and T4. The second concept we are going to talk about is switching. We will go through three types of switching. Circuit switching, it will first seek out a physical path from sender to receiver. An end-to-end path must conceptually established before data is sent. Message switching, no path is established in advance. The message is stored in first switching office and forwarded later one hop at a time. The problem of this type of switching is there is no restriction of block size. Imagine a host sends out an extremely large message. It might overflow the switch which handles it. Packet switching, based on message switching, we now place a restriction on block size to allow the packet to be buffered in main memory at switching office. It can solve the problem of message switching, and it will improve the response time and the throughput of network. Now, let's have a further look on these switching approaches. In this telephone network example, physical copper connection is set up when the call is made. For packet switching, we use an example of computer communication. The packets sent out are routed independently, which means no path needs to be set up in advance, and each packet might go through different paths. We then try to use different dimensions for showing the differences between these three types of switching. We look at the time dimension. For circuit switching, most of the time is taken for setting up the connection. For message switching, message is forwarded one switch by one switch, so the forwarding is sequential. For packet switching, a message is divided into smaller packets, and this packet can be forwarded on the network at the same time. It explains why we say packet switching will improve the response time and throughput of the network. In the end of the introduction to switching, we do a comparison between circuit switching and packet switching. It is a thoroughgoing comparison, including core setup, physical paths, routing, bandwidth, congestion, charging, and so on. That's it for this section. Thank you.